Hello everybody, we are the Johnsons.
Go.
So today's video is going to be dedicated to related rates. And related rates are problems that are looking to find something that is changing in relation to other rates that are already known. So we have a few guidelines, and the first one is always going to be to draw your diagram. Then your next step is going to write any rates that are already known, and rates are also known as derivatives. So they're all going to be given in respect to time. And then you're going to write the formulas. Depending on your problem, your formula will be different. Then you'll be able to find the derivative of that formula and begin substituting all the other known values. You are blowing up a balloon at a rate of 300 cubic inches per minute when the balloon has a radius of 3 inches. How fast is radius increasing? Good question. Let's answer that. Okay, so what do we know in this problem? It first tells us that it is blowing up at a rate of 300 cubic inches per minute. So that's already one rate we know. And what else do we know here? It says when the balloon has a radius of 3 inches. So that's another thing that we know. So first step in all our problems is going to be to draw a diagram. So our diagram for this one is a balloon, so we're going to draw a balloon. And we know that it has a radius of 3 inches. So R equals 3. So we already circled this rate, and that's all we have to place into here. So the rate of this is going to be 300, and that is dV dt. Because that's the volume, that's how big it's getting. And it's asking us to find when the balloon has a radius of 3, how fast is the radius increasing? So that means we have to find dr dt. So the formula we're going to be using for this one is the volume one and that is 4/3 pi r cubed because it's volume. And now our next step is going to be to find the derivative of that formula, like 4/pi. Don't get confused with the pi because it's just a number. Times 3r squared dr dt. Okay? R squared dr dt. So our dr dt is going to be what we want it to equal to, and that's the over here. So dv dt, we already know what that is. That's going to be 300. Let me put this over here. And this is when we begin our substitution step. So 300 equals 4 pi times 3 squared, because the 3 is the radius over here. Oh, sorry, r equals 3 here. And we plugged in dv dt. So then we just simply solve for it. And then you end up getting 300 equals 4 times 3 squared is basically 4 times 9 pi. So 300 equals 36 pi. And this is all still dr dt. And you're basically going to separate this to get the RDT by itself, because that's what we're solving for. And make sure when you're entering this into the calculator, you're putting parentheses around the bottom. So then once you isolate the RDT, you are left with 2.65 inches per minute. So basically that means when the radius is 3, the balloon is increasing at a rate, the radius is increasing at a rate of 2.65 inches per minute.
Good.
Alright, so for problem number 2 it states, the length of a ladder leaning against the wall measures 5 feet. So that means that this ladder right here is 5 feet. Its base is 4 feet away from the wall. This is its base, so this length is 4 feet. And it is sliding away from the wall at a rate of 2 feet per second. So that means it's going this way at 2 feet per second. Find the rate at which the ladder is sliding down the wall. So we're trying to find this rate. Because, I'll show you. So as the ladder is sliding this way, at the same time, this part of the ladder is going down. See that? How it's going down? Alright, so what are our knowns? Or these are our knowns here, but I'm going to write them right here. So we know that the ladder is 5 feet. that the rate dx dt is equal to 2 feet a second. And we're trying to find dh dt. Or dy dt, sorry. Alright, so how do we start? So we're going to use this formula. This is Pythagorean theorem, because if we can see it right here, it's a triangle and it has a right angle. So we're going to use the Pythagorean theorem formula, and we're going to take the derivative. So to take the derivative, I'll send it. What you're going to do is bring down the 2, and you're going to put it in terms of time. So you're going to do it like this, dx dt plus 2x dx dt and 2y dy dt, and this is going to equal to 0. The reason that you don't take the derivative of the c is because the ladder is constant. It's constantly at 5 and it doesn't change. See, it's gonna be 5 no matter what. And then what you want to do is you plug in your knowns. So I'm going to plug in my knowns here. So it's going to be 2x, which is equal to 4, dx dt, which is equal to 2, plus 2y. Oh, to find y, you have to do the actual Pythagorean theorem problem. So it's going to be, okay, so to find the actual y, this part here, you're going to do the actual Pythagorean theorem problem. So you're going to plug in the x, which is 4, equals c, which is 5 feet, which is 5, right? 5 squared. And so 4 times 4 is 16 plus y squared equals 25. Subtract 16 from both sides. What is that? 9? Yeah, 9. And then when you do the square root, you're going to get y equals 3. No. Okay, so now that you have your y, you can plug it into here. So the y is going to be equal to 3. And the dy dt, you don't know yet, so you're just going to leave it alone. And that's going to equal to 0. Now what you want to do is you're going to do some algebra to move this stuff around, so you know what dy dt is. Now when you get here, all you have to do is divide by 6 to both sides. And your answer is going to be dy dt equals negative 16 over 6. Yeah, that's it.
Okay, so today we're going to be doing the third problem, which involves a rectangle. So the width of a rectangle is increasing at 4 centimeters per second, and the length is decreasing at 3 centimeters a second. How fast is the area changing when the width is 10 centimeters at length, and the length is 15 centimeters? So, our knowns is that it's increasing by 4 centimeters, the width. So, this width is increasing by 4. And the initial width, or the width we're trying to reach, is 10 centimeters. And the length we're trying to reach is 15, while the rate it's decreasing is at 3. So, oh, by the way, it's going this way. So here is where we're going to put our knowns, and the rate at which the width is changing would be dw dt, and that is 4 centimeters per second. Yeah, 4. And dl dt would be the rate at which the length is decreasing. So we have dl dt equals 3 centimeters a second. So just 3. And oh, it's negative because it's decreasing. So when we plug in dl dt to the equation, we're going to plug it in as negative. And how fast is the area changing? When the width is 10 centimeters, so we know our width equals 10, and our length equals 15. So the formula that we're going to be using is area equals length times width, the basic formula for a rectangle. And to find the derivative of this, we need to do product rule, which is f prime times g plus g prime times f. So when we plug in our values to that, we'll get f prime of x equals dl dt times w plus dw dt times L. So this is going to be the formula that we use for solving this equation. So let's write that down here. We have dl dt times w plus dw over dt times L. So now from here we just plug in values and then we do basic algebra. So dl dt is 3, negative 3. So we plug in negative 3 times 10 plus dw dt, which is 4, times 15, which is length. So from here, you just multiply, so you get negative 3 times 10, negative 30, plus 4 times 15, which is 60, and that comes out to 30. So when you write it as your final answer, you would get dA dt, because we're trying to find the rate at which the area is changing, which is why we have dA over dt, equals 30 centimeters per second. That is all.
Now you try. We have 2 extra practice problems on the worksheet.
Thank you.
We are the Johnsons.